Hello, my name is Lauren and welcome to the Theoretical YouTube channel, where we've gone like 4 days without Disney, and I'm currently in withdrawal. Anyway, in school this year I decided that calculus is way too hard, and so instead I'm taking AP Statistics. And pretty early on in the semester I discovered a method that will finally help us answer a question that has been plaguing Disney fans for generations. What is Cinderella's shoe size? So how do we determine the size of our feet? Well, first we need to understand a few basic concepts. First of all, we know that both men and women's shoe sizes are both normally distributed, which, if you have no idea what that means, it has to do with this bell curve. No! The hump in the curve is the mean, or average, of the data, and it's symmetrical on both sides. The area under the curve is the percentage of people who fall into these specific data ranges. If you're pretty normal, then you're in the middle with a ton of other people, but if there's less of you, you're on the outsides. The whole thing is 100%, halfway is 50%, and so on and so forth. But more importantly for us, there's a few other measurements we can take. What we really want to know is the standard deviation, or the spread of the data. It's like the average distance between the data points and the mean, and it lets us scale the distribution. For instance, the standard deviation for size of bacteria is much smaller than the length of giraffes' necks. Basically, we need both mean and standard deviation to figure out how many people are under a section of a curve, because calculus is hard and integration sucks. Fortunately for us, there's a couple studies out there that we can use for our data, because most tend to agree that we have a mean of about 8 and a standard deviation of 1.5, therefore making the graph look kind of like this. Okay, so our next step is to use an equation called the z-score. Cool name, right? In order to figure out the percentage under the curve. A z-score is a specific number that correlates to a universal chart called Table A. Not so cool name. And it tells us that the percentage of people are above or below a specific value. In this case, whatever Cinderella's shoe size actually is. The z-score is equal to x, the actual shoe size, minus mu, the average shoe size, over sigma, the standard deviation. But here's the catch. We're actually trying to find Cinderella's shoe size, which means we can't use the equation the way it was intended. We have to work backwards. Instead of computing her z-score with the data and then trying to figure what percentage of the population she shares it with, if we can figure out how many people she doesn't match, then we can know what percentage of the population she really is. Here the phrase 1 in a million might actually help us. Because if Cinderella really is the only one with her shoe size out of 1 million people, then she represents 1/10,000th of a percent of the people in her kingdom. Therefore, we can match her with a z-score. And since we already know both mean and standard deviation of women's shoe sizes, we can solve for the actual size of her foot. The only problem left is that we have no idea how many people are in Cinderella's kingdom. Well, actually I've got a few ideas. First of all, the fairy tale suggests that Cinderella is the last girl in the whole kingdom to try on the glass slipper, and we know that men and women take up about the same amount of a population. So now we just need to know how many people lived in the average kingdom back then, and then divide it in half. Well, we know that Cinderella was originally written by Charles Perrault in France in 1697. The story takes place in France, and actually that's probably when it takes place too. But France was kind of a country of its own by then and didn't really have kingdoms anymore. However, there was undisputed land between France and what is now Germany, which makes it kind of a prime location for the fictional kingdom of the Disney flick. Or you could consider the fact that it didn't take that long for the prince to have everybody in his kingdom try on a single shoe. Maybe he's not as powerful as we previously given him credit for. Maybe the prince and his father weren't royalty per se, but powerful lords instead. Honestly, that's way more likely for our model, and besides, much more likely to have occurred within French borders. Why do we call him a prince? Maybe it's because it sounds a lot more romantic than lord or duke. Yeah, Disney dukes don't necessarily have the best reputations. Okay, so assuming that the villages under the prince's feudal system were about average size, that's like 6 square miles. And in a pretty large control of land, that's maybe 100 villages. Historically, French villages consisted of about 100 people per square mile. So that's about 600 people per village. And with 100 villages, that's 60,000 people in the kingdom. That's still quite a few people to invite everybody to your ball, but whatever. Alright, so with half the population being men, we know that Cinderella is 1 in 30,000. She represents 0.003 thousandths of a percent of the total population, which means that she has a whopping z-score of negative 4.1735. This may not seem all that impressive, but you have to realize that negative 4 is such a low number that it doesn't even appear on table A. Cinderella is so far from the mean that most math textbooks don't even print her score. It's probably considered a waste of ink. Anyway, now we can plug the z-score into our equation where we know that the mean is 8 and the standard deviation is still 1.5. And with the powers of algebra, we know that Cinderella's shoe size is 1.7. Do they even make shoes that small? Assuming that she'd be actually wearing a size 2, then yes, they do actually make shoes this small. Then again, who's saying that her shoes are small at all? If we convert our negative z-score of 4.17 to a positive 4.17 and then run our same calculations again, we get that Cinderella's shoe size could be 14.25. But, you know, that's not really as elegant, and the original fairy tale had the two stepsisters hacking off parts of their feet to fit in the shoes, so I'm guessing it's a size 2. And if that's the case, then a modern Cinderella isn't so impossible as the story would have you believe. Because if she's like 1 in 30,000, the population of the United States was about 330 million in 2017, then there's like 11,000 Cinderellas running around our country alone. And if the world's population is about 7.6 billion, then there's probably like 250,000 Cinderellas all over the globe. So if any one of you guys know that you have size 2 feet, be proud to wear those glass slippers, because you may not be 1 in a million, but you're close enough for me. In case anybody's wondering, I wear a size 8, so there's no Cinderella here. Oh well, thanks for watching this video, and we hope you learned something, or at least liked it. Either way, don't forget to hit that subscribe button and ring the little bell in the corner for more cool content just like this. Well, not just like this, that would get a little bit repetitive. Anyway, thanks for watching and we'll see you later.